All right, so I had mentioned yesterday that the original packet I gave you was kind of weak on the notes for logarithmic functions. So that's what those additional pages have. There's a couple of slides that overlap that show up on both of them, but that shouldn't be too big of a deal. I'm also I have to get to logarithms today because that shows up on the homework. I didn't realize that until recently, so we should be fine. They're very similar. So just to take off from yesterday, what type of function is this? There's two types of functions that we're studying this unit. So you got a 50-50 shot if you know what the two functions are. This one is exponential. Sure, the variable's up in the exponent. So all we got to do is identify A, C, H, and K. We're going to do the same thing when we get to logarithmic too. What's A here? 3. What's C? C is 1, sure. What's H? Positive 4. And what's K? 0. We know that exponential functions have horizontal asymptotes at K. You don't have to do it now, but just maybe as a habit, maybe it might be a good idea, just so you don't forget. And this one's going to be on the x-axis at y equals 0 because of K. Now we need to come up with starting points. Starting points come from the base. What's the base of this exponential function? What's the b here? 2. So I want to start taking 2 to certain powers. Is this an example of a growth or a decay? Why a growth? The base is greater than 1. So what inputs, what x's did I recommend? 0 and positives. Sure, 0 and positives. I like using coordinate notation, but since there's not that much space on the slide, and they've already put these tables here, let's just use the tables. So here are my inputs, 0, 1, 2, and 3. These are the parent points. Think of these as starting points. These have not undergone the transformations yet. We haven't transformed them yet. Okay. Now let's come up with the outputs for that parent. So like all I'm doing right now to get these starting points is I'm taking 2 to the x power. What is anything to the 0 power? 1. What is any number to the first power? Itself. 2 squared is? 2 to the third is? So these are going to be our starting points, and we're going to transform these according to the formula that I gave you yesterday, and I have given you also in the past, and I'll be nice and write it again. It's going to be x divided by c plus h, y times a plus k. But since c is 1 and since k is 0, I can ignore those in this case. Anytime h or k is 0, you can ignore it. Anytime a or c is 1, you can ignore it. So what's the only thing I have to do to all the x's here? Add h, which is 4. What do I have to do to all the y's that I have here? Excuse me? Multiply by a, which is 3. So if I do, how should I, let's see, here, let's just do it. I thought they were going to put an extra table here, but I guess let's just squeeze it in here. So all of these x's are going to be plus 4, plus 4, plus 4, plus 4. And all of these, are the y's are going to be times 3, times 3, times 3, times 3. So my new points are going to be 4, 5, 6, 7, and then 3, 6, 12, 24. You could scale it if you want to, but if you can at least fit 3 points, that should be enough. And it looks like I could fit 3 here. So let's put a point at 4, 3. Let's put a point at 5, 6. Yeah, because it's stretched. 5, 6. And 6, 12. So I'll hug the horizontal asymptote, and it will look something like that. Shina, what's the domain here? Yeah, the domain of all exponential functions is going to be all real numbers. Do you remember how before when we were doing regular equations for exponentials, why you didn't have to check for extraneous? That's kind of why. How about the range? This is above the asymptote, so yeah, we're gonna go from 0 to positive infinity. And then where's the asymptote at, Elias? Say it better. There you go. I remember that yesterday. You were confused by that. Yeah, good. Halen Hall, what's my end behavior? No. As x approaches negative infinity, which means that we're going left, well, what's y doing? It's going to the asymptote. As x is going to positive infinity, which is the right arrow, this is going to positive infinity also. And we already said, is this a growth or a decay? We'll do one more exponential, and then we're going to have to jump to logarithms because one of the homework has to deal with logarithms. Ooh, fun. What's different about this? Well, it's a decay, yeah. Because the basis of a proper fraction, this is a decay. This might be the first decay I remember us doing. I don't remember doing another decay yesterday. So let's still identify A, C, H, and K. Stephanie, shush. Stephanie Felix, what's A? -1. Stephanie Felix, what's C? Good. What is H? Excellent. What's K? Alrighty. Mohammed, you got that? Good job, Mohammed. Doesn't really matter the order you do this, but if you want to go ahead and put the asymptote now, this will be at 5. Whoa, there's no way I'm going to be able to fit this graph here. This graph is crazy, right? Can you already tell what's happening on the graph, though? It's flipping. It's doing like a vertical flip. It's flipping over the x-axis. So this graph is going to actually be below the asymptote, not above. We need parent points. Okay, we need starting points. Is this a growth or a decay? Yeah, this is a decay, so I should use what? Yeah, 0 and negatives work great. So 0, -1, -2, -3. What is any number to the 0 power? 1. Okay, now the reason why we use negatives is because what the negative exponent is going to do, remember these numbers that I'm putting here are taking the place of this x. So what that negative number is going to do is it's going to flip the base. So 1/2 to the -1 power is the same thing as flipping the 1/2. What's the reciprocal of 1/2? 2, and taking just 2 to the first power. What is 2 to the first power? What's 2 to the first power? 2. What's 2 to the second power? 4. All the negative is doing is flipping that 1/2 to make it into a 2. And what's very good. All right. Now I want to apply that formula that I used based on what I learned. That here I can ignore the C and the H. Those aren't going to do anything. So all I got to do, it looks like the only ones that are going to be affected are going to be the Y's, because A and K both affect the Y. So I could even just go ahead and write down, I know there's going to be 0, -1, -2, -3. That's not going to move, because C and H affect the X. But I have to go to all of these and go times -1 and plus 5, times -1 plus 5, times -1 plus 5 times negative 1 plus 5. 1 times negative 1 is negative 1 plus 5 is 4. Then negative 2 plus 5 is 3. This is negative 4 plus 5 is 1. Negative 8 plus 5 is negative 3. Mental math in the house. So 0, 4 is here. Negative 1 and 3 is right there. Negative 2 and 1 there. And negative 3 is here. So if you were to flip that back over the asymptote, you would see it look like a decay, but it is just a decay that just flipped over the asymptote.
May I have your attention, please? Please excuse this interruption. If anyone is taking the ASVAB this morning that did not receive a ticket, please go to the theater lobby right now. They're going to be starting the test right away. Thank you.
Mr. Kirksey, what's the domain here? You're the man, Randy. Mr. Kala, what's the range? Very good. Yeah, huh? Yeah. Very good. Since this flipped, huh? Oh, yeah. I'm sorry. The 5. Yeah, I was focused more on the negative infinity part. Yes. Since this flipped, now this is not above the asymptote, it's below. So we're starting at negative infinity, and correct. It doesn't go to 0. It goes to 5. All right. Cade, asymptote. You're the man. After Randy. Randy's the first man. You're the second man. And then Moosey, Mr. Showoff, you can do end behavior. Well, let's just go in order. Let's do negative infinity first. It doesn't really matter, but let's just do. Good, and y is also going to negative infinity because the left arrow is going down. And then as x goes to, yep. Excelente. Any questions there? All right, so let's just kind of jump then to, this should be on the new packet. Some of these might be on the old packet, but let's go right here. I think this was on both. All right, so what if we're given logs? Well, the only thing really different, there's a couple things different about logs. Okay, where you find A, C, H, and K, which if you look here, A is now going to be in front of the log. C is going to be in between the base of the log and the x. It's still whatever's in front of the x. H, if you're going to have an H, it would need to be inside. This one has to be in a parentheses. And then K is off to the outside. But we're still going to identify it. We still have a base, just like the exponential. I'll just show you what to do a little bit differently. The other thing that's different is the shape. Now, these don't really have names. It's not like we call them like logarithmic growth and logarithmic decay or anything. So when that base that I just drew an arrow to, when that's greater than 1, this is the shape it takes. As you are going to the right, as you are increasing, the y is also increasing, but at a decreasing rate. It's increasing, but it's continuing to flatten out. It never gets completely flat, but it just continues to get flatter and flatter. And when the base is a proper fraction, now as we go to the right, as x is increasing, y is decreasing, but also at a decreasing rate. That kind of looks like a decay. The other, besides the shape, the other thing that's different is instead of a horizontal asymptote, take a wild guess what a logarithmic function has. A vertical asymptote. Instead of being at y equals k, this is going to be at x equals h. So whatever h is, that's where I'm going to draw a vertical asymptote. Okay. These are boring. These are just parent functions. Let's try to get to some that have some substance to them. Boring. Boring. This we already talked about. You can look at these on your own. Come on, show me some good ones. Alright, here we go. Here are some good ones. So look at this first one. There's a base 3 log. Let's identify A, C, H, and K. What's A here? 1. What is C? What is H? Yeah, with these there has to be the parentheses. If there's going to be an H, it has to be in a parentheses. What's K? 0. K is 0. There's nothing out there. So there's only one transformation here. What's the transformation? This one's asking us to describe it, so you might as well. You might see those on the... Horizontal translation 4 units left. Before we answer all these other questions about intercepts and then behavior, I guess intercepts we can already answer now, but we'll do that afterwards. Let's just graph it first. I want to show you how to graph. Do they give us more space here? Please get done. Son of a gun. All right. Man, there's not a lot of space here. Where can I fit this in? Do you guys have more space on your paper? You can do it off to the side. You have space. I said you have space in the margins there. Like just put it like in that middle little column. Just like with exponentials, we're gonna look at the base. Okay? And really, I would treat it exponential. So like, if we go back 5 minutes ago when we were covering exponentials, and they would have said like y equals 3 to the x, what are some parent points we would have picked? It would be sure like 0, 1, because don't write this down yet. Okay, just follow along, right? Because 3 to the 0 is 1. What are some other points we would have picked? 1, 3, 2. What's 3 squared? 9. 3 to the third is 27. All right, but that's if it's exponential. What's the relationship between exponentials and logs? They're inverses. So all we got to do now is switch the points. Instead of 1, 0, okay, my starting points here are going to be, I'm sorry, instead of 0, 1, it's going to be 1, 0, 3, 1, 9, 2, 27, 3. You just switch the x and the y. And then that's it. Once you have that, now you can apply the transformations. I'll just do it off here to the side because I just don't have a lot of space. Oh, darn it. Whatever. All right, I'm just gonna do it in my head then. Like there's not that much here anyways. K is negative. H is -4. So what does H get applied to? What do we apply H to? What do we apply H to? The x's. So I'm gonna get all these x's and I'm gonna take away 4. So then that would be -3. The 0 stays the same. That would be -1. The 1 stays the same. That would be 5 and the 2 stays the same. That would be 23 and the 3 stays the same. Even though that one's not gonna really fit, but I can fit the other ones. What type of an asymptote am I gonna have? And look, I can even write that down already in here. What type of asymptote? It's vertical, so it's going to be x equals, and x is equal to whatever h is. What's h here? -4. So I'm going to go draw an asymptote at a vertical one at -4. And now let's put some of the points that we got. -3, 0. -1, 1. 5, 2. Okay. Just make sure you don't breach the vertical asymptote. Okay, let's answer some of the questions now. Tommy, what's the domain here? Good. From left to right, we start off at -4, we go to positive infinity. What's the range? Very good. If exponentials have an all real numbers domain, logarithms have an all real numbers range. So this is negative infinity to positive infinity. Okay, here's some new, it's new terminology in this packet, but we've seen it before. Intervals. Intervals have to do with a domain. We only have one interval here in the domain. This is not changing directions or anything. So is this always increasing or decreasing? Yeah, this is always going to be increasing. So we're increasing between -4 and positive infinity. Okay, intercepts. We can tell by looking at it, or at least we can tell the x-intercept by looking at it. Yeah, you can tell the x-intercept. But let's do those algebraically. We'll do those right underneath. So let's jump to end behavior. As x approaches negative infinity, as x approaches positive infinity. What are we doing as x is going to negative infinity? Yeah, it is going down to negative infinity. And what are we doing as x is going to positive infinity? Yeah, also going to positive infinity. And actually, you know what? I take it back. X is not, the first x should not be negative infinity because of the asymptote. Yeah, that should be -4. So as x is going to -4, then y goes to negative infinity. It's never going to reach negative infinity. As x is going to positive infinity, then positive infinity. All right, let's try to do the intercepts. Let's see if we can do the intercepts real quick. Who remembers from yesterday? How do we find the x-intercept algebraically? How do we find the x-intercept algebraically? Put a 0 in for y. So 0 equals log base 3 of x plus 4. We already have a single log. How do you get rid of a log? Change to exponential. Not change of base, change to exponential. So 3 to the 0 power, which 3 to the 0 power is 1. That's equal to x plus 4 minus 4 minus 4. We get -3. But we knew that already. We already knew we were going to cross the x. We already knew we were going to cross the x-axis at -3. So here, one intercept is -3, 0. Now let's find the y-intercept. How do we find a y-intercept? Yeah, plug in a 0 for x. So y is equal to log base 3 of 0 plus 4, which y is equal to log base 3 of 4. That's going to be irrational. I guess you can round. What's log 4 divided by log 3? Put it in the calculator. Ready, set, calculate. Should be 1 point something. And we can tell even from our kind of graph that it's looking like it's going to cross just above the 1. What is it? 1.26? Okay. So it's rounded, but we can say around 1.26 is equal to y. Y is approximately equal to 1.26. So 0, comma 1.26. Okay. Let's jump to the one below, to this one here below. Let's identify A, C, H, and K. Come on, Haven, you can do it. Put a little power to it. What's A here, Haven? It is 1. What is C? What's H? And what's K? Did Mohammed give you that answer? Mohammed, stop giving Haven the answer. So, Caitlin, describe the transformations. Good. So I don't have a lot of space here, so I'll just put H trans for a horizontal translation. 2 units left, and then vertical translation, 4 units down. Let's go ahead and do the graph first. Where are we going to have an asymptote? ¿Dónde está el asymptoto? At x is equal to -2, which is a vertical line right through -2. We don't have a lot of space here, so we'll just do like the calculations in our head. I'll write the parent points first. This is a base. Oh, it's another base 3 log. Okay, so we can use the same parent points. Somebody give me the first parent point for a base 3 log. Yeah, instead of 0, 1, 1, 0, what will be another one? Yeah, instead of 1, 3, 3, 1. What else? Good. 9, 2 instead of 2, 9, 9, 2, and then 27, 3. But we're not even going to be able to fit that one. So you know what? Let's just save space. Let's just work on these 3. Meredith, how are we going to transform these points? From? Yeah, take away 2 from the x's, and then it's up there. Take away 2 from the x's, and then take away 4 from the y's. It's the same formula. It's still x over c plus h y times a plus k. Since a and c are being multiplied and divided, if those are 1s, you can ignore them. So here a and c are 1s, I can ignore them. All I'm going to do is take away 2 from all the x's, take away 4 from all the y's. So we can do a mental math race. That'll be -1, -4, 1, -3, 7, -2. Anybody disagree with that? Musi already has it on his paper. -1, -4 is down here. 1, -3 is here. 7, -2. So 7, -2 is there. Connect the dots, and then just respect the vertical asymptote. Gabby, what's the domain? Say it again. Not negative 1. So okay, so if you noticed on the other ones, on exponentials, it was the range that was affected by the asymptote, and it was like either above the asymptote or below. So here the domain's either going to be to the left of the asymptote or to the right. Here we're to the right, so the lowest we'll go is the asymptote. Where's the asymptote? Not at 1. It's at -2. The vertical asymptote's at -2. You want to sit closer? Sit. No. Oh, I heard you say 1. You just said a bunch of numbers. And then up until where? Positive infinity. Randy, you're having a great day today. And you're dressed in style. It's nice. Range? Yeah. Yeah, range is just going to be infinite good. Negative infinity, positive infinity. Is this increasing or decreasing as we go to the right? If you're on a roller coaster, is this going up or down? Oh, you know what? And I just realized I forgot to do that on the last one. I put the interval, but I forgot to put what it was doing. So this one here was always increasing, because if we were going on a roller coaster, we'd still be going up. It'd be flattening out a little bit, but it would still be going up. So how about this one? Yeah, same thing. It's an increase, and the interval is same thing, from -2 to positive infinity. The intercept we'll find at the end. I'll let Stephanie Felix take care of end behavior. What's the left arrow doing? Yeah, it's going as x gets to -2. What's the y doing? What's the y doing? As we're going to -2, what's the y doing? Yeah, the y is going down to negative infinity. And for the right arrow, where's the right arrow going for the x? Yeah, the x is going to positive infinity. And what's the y? Very good. Positive and positive. Let's see if we can find the intercepts. Well, that x-intercept is going to be big. That's fine. How do we find an x-intercept? How do we find x-intercept? Okay, put a 0 in for y, so let's do that. 0 equals log base 3 of x plus 2 minus 4. So we got to get the log by itself. We would add 4 to both sides. So 4 equals log base 3 of x plus 2. And then, how do we get rid of the log? Switch to exponential, but now 3 to the 4th power, is that 81? 81 is equal to x plus 2, so we were correct. It's going to be a big number. This is crossing the x-axis at 79,0. Yeah, convert to exponential, so it's this 3 to the 4th power, that gives me 81, and then that allows the x plus 2 to break free. So one intercept is at 81,0. Now the y-intercept. Question or answer, Dennis? Okay. Yeah, put in a 0 for x. So y would equal log base 3 of 0 plus 2 minus 4. I mean, you can go ahead and just basically put that in the calculator. Take log base 3 of 2 and then take away 4. It looks from the sketch that we did, it's going to be negative 3 point something. Maybe you can confirm that. Somebody, ready, set, calculate. Negative 3.04. Does everybody agree with that? Elias? Okay, I'm having trust issues right now. Let's see. Log 2 divided by log 3 equals minus 4 equals, I'm getting a negative 3.37. It's Randy's fault. So 0, comma, negative 3.37. Boring. Ooh, ln's. Yeah, we can do that next week. We don't have to do ln right now. Let's do the one on the right over here with the 1/2 in front. Okay. Describe the transformation. Okay, let's identify A, C, H, and K. A, C, H, K. Lamson, what's A? 1/2, good. What's C? C is 1, good. What's H? No. 2, good. K, 0. Describe, Caitlin, no, wait, who was it? Yeah, Caitlin. Describe the transformations. Okay, you can, normally we write that at the end, but, so I'll just say horizontal translate 2 units to the right. Okay, what else? Something about 1/2, you just don't know what that 1/2 is doing? It is a compression on which direction? No! Vertical, A does vertical. So vertical compress of 1/2, a vertical compression of 1/2. All right, so let's try to graph now. We're expecting a asymptote at 2. And we need some parent points. Look, I got all this space over here, so let's put the parent points over there. But look, the base is different here. Caitlin, you want to try giving me some parent points? This is a log base 4, so just think about 4 to the x. But then we're going to flip it. Maybe if you wanted to think of it, you could even think of it as 4 to the y. Maybe that'll make more sense. So the base is greater than 1, so we're still going to want to pick zeros and positives. Okay, we're going to use those, that's fine, but then give me the first one. What's 4 to the 0 power? 1, but instead of putting 0, 1, we're going to put 1, 0. How about, what's 4 to the first power? Huh? Yeah, it's 4, but so instead of putting 1, 4, we're going to put, yeah, 4, 1. Fine. It's going to, the compress is going to make it a fraction, but whatever. 4? Yeah, 16, 2, because 4 squared is 16, but you would just put the 2 where the y goes. Yeah, let's stop there, because the next one's going to be 64, 3. That's going to be too big. Let's see if we can fit those. Even that's going to be hard to fit. Huh? You're not taking anything to the power of 1/2. You're multiplying by 1/2. The 1/2 is an A. So we're just taking half of the numbers. So now when we apply the transformations, we can ignore C and we can ignore K. So we're going to get all the X's and we're going to add 2. And we're going to get all the Y's and multiply them by 1/2. So we end up with 3 and half of 0 is still 0. We're going to end up with 6. Half of 1 is 1/2. And we're going to get 18 and 1. Man. Whatever. I'm not going to scale this. We'll just guess where 8. It's kind of a sketch anyways. So 3, 0, we know where that's at. 6 and 1/2 is there. And then 18 and 1 would be like somewhere over here. Connect the dots, respect the asymptote. That'll be something like that. You're an excellent dancer, Moosey. Straight out of a Paula Abdul video. Didn't I see you dancing behind J-Lo at the Super Bowl? Oh, no, I don't think that was him. He looked like you though. Alright, see who haven't I called on today. That's all. Let's go with Abby. Abby, what's the domain? No. Anita, what's the domain? Good. 2 to positive infinity. Tabarak, the range? Have you looked at the board even like once today? Twice? Yeah, no, trust me, I've called Mohammed. Mohammed's not here right now, but if you leave a message, he'll get back to you as soon as possible. Shina, what's the range? Yeah, our real numbers. Negative infinity to positive infinity. Where's the asymptote at? Is this increasing or decreasing? Yeah, this is increasing everywhere, and that's from 2 to positive infinity. I'll skip the intercepts here just because of time. We've done intercepts enough, I think. What's the end behavior? Let's see. The first X is the left arrow is not going all the way to negative infinity with X. Where is it going? To 2. So as X approaches 2, Y is going to negative infinity. And then as X approaches positive infinity, what's Y doing? Also positive infinity. Cool. So we're still going to work on this packet next week, but this should be enough to at least get you through the homework. Let's try this page. Change it up a little bit. There's a matching. If you look at the graph, I could tell that 2 of those are exponential and 2 of those are logarithmic. How do I know that without even looking at the answer choices? No, say better words. The asymptotes. Look at the asymptotes. I see 2 horizontal asymptotes. I see 2 vertical asymptotes. The vertical ones are going to be the logarithmic, and the horizontals are the exponentials. Okay, then if you want it to be more specific, it looks like for the exponentials, one of them, like this one over here, looks like a decay. This one over here looks like a growth. If you wanted to be more, okay, you know what? Let's do that. Let's start with the exponential ones. So if I look down here, the 2 that are obviously exponential are B and D. Which one of those is a growth? D is a growth, yeah, because the base is greater than 1. Now, if you wanted to confirm it, where should the vertical asymptote be for that one? It should be at 2. And the one here that is a growth does have an asymptote at 2, so sure, this is going to be D. And if you look at the decay, where should the horizontal asymptote be there? At -2, and it is, so this is B. Okay. For the logs, it might be a little bit harder, like to look at the points, but we can definitely look at the asymptotes. And there's clearly two different asymptotes there. They're both vertical, but one's at 3 and one is at 4. But what's another thing that's happened differently between those two? Yeah, one of them is flipped vertically. So, if we look at the basic shapes from that logs take. Hey, what happened to that? Oh, here it is. Okay, if we look at those are the two basic shapes for logs. Specifically, look at the one where the base, where the base is greater than 0. Because if we go back and look at these, both of those bases of the logs are greater than 0. So the one that hasn't flipped is the one that should look like that, which of the two logs, which is the only one that looks like that. The last one, sure. And you can confirm by looking at the and you know what? I'm an idiot. Sorry, I circled the wrong. I meant to circle here. Sorry, here are the vertical asymptotes. So that last one, the one that hasn't flipped, should be A because there's no negative in front there. That vertical asymptote should be at 1. Is that vertical asymptote at 1? Yes, it is. So then this is A, and then this is C. An exponential graph translated 2 units. Oh, so here they want you. It looks like they want you to write. So let's see if we can do that. Let's write an exponential graph. Well, I don't know. Maybe they want you to graph. Whatever. Let's just write it. I mean, we've graphed already. If we're let's see, A, C, H, K. If we're translating 2 units up, what's going to be 2? K. If we're going 4 units to the left, what does that mean? H is -4, and a vertical stretch of 2 is A being 2, C is 1 here. So if this is exponential, we would have -2 times. They don't give me a base, so we can pick any base. Just pick any base. Caitlin, what's your favorite number? It's a boring number. 23, that's way too big. 5, thanks. Alright, so whatever, we can pick any number there. And that's going to be to the power of x minus 8, so this becomes an x plus 4, change the sign, and then plus 2. And if you wanted to graph that, you should be able to. Hold on. Let's do this one. A log that's reflected over the y-axis. If we're reflecting over the y-axis, what does that mean? No, it means that C is negative. And translated 2 units down. So K is -2, so H would be 0, this would be -1, that would be 1. So if A is 1, we can just write log. You can pick any base. Quick, pick a base, pick a base, pick a base, pick a base, pick a base. 4, fine, 4. Somebody said 4, I heard that first. Okay. Then I'd have to have the -C, then the parentheses. Well, H is 0, so actually we can just get away with just that. And then K is -2. There you go. All right, we'll leave it at that, and we'll continue working on Monday.